We're going to go over problem 4 because that should give you everything you need to know to more or less do the rest of the assignment. Okay, before I talk about the problem in particular, I want to talk to you about this relationship, which we discovered in the lab, which is that impulse causes change of momentum. I first want to talk about two things. Number one is, why is this true? We did more or less establish it experimentally, but it really flows from Newton's second law. In other words, if you believe this is true, then this must be true. Here's what I mean. Let's look at impulse. Impulse is defined to be a force acting over a time interval. Now, it could be a constant force or it could be just an average force. So change of momentum for objects with constant mass. So if the mass is constant, then the only way momentum is going to change is with a change of velocity. Okay, so this is the impulse. It has a name. It's called the impulse momentum theorem. But that is, I have no idea why it's called impulse momentum theorem. It really is just a restatement of Newton's second law. Here's what I mean. Let's take both sides and divide by delta t. Just a little algebra here. Delta t divided by delta t goes to 1. So we're left with force equals, and the m is fine. What is delta v over delta t? It's really average acceleration, or a. Well, here you go. That is nothing more than Newton's second law. F equals ma. So, who knows why it's called the impulse momentum theorem? This really is Newton's second law. But this is where I'm going to edit out. So when you see my hands waving, that's where I'm going to edit. Okay. So let's put that back. Let's bring this back down again, because it's a very useful version of this impulse momentum theorem that's going to help you solve problems. So we have the impulse is F delta t equals m delta v. This is a lovely little way to express it, and it's going to help you solve problems. For example, let's look at problem number 4 on the bottom of the page here. We are told that a golf ball exerts a force on a golf club exerts a force on a golf ball. It gives us the average force, it gives us the time interval, and it tells us the golf ball is initially at rest. And the question is, how fast will this golf ball be moving immediately after the club is done smacking it? Well, this is the perfect way to think about it. We're told information about the impulse. We know that the momentum is going to change, is going to equal that. And then we're basically asked for what is v final given that v initial is equal to 0. So here we have, I'm just going to rearrange it to put it in a more useful form for our purposes. We're interested in the velocity change. So doing a little algebra, we're going to bring F delta t over to the right divided by m. And since this is v final minus v initial, and that is 0, then here's the answer right here. We take the force, the average force, times the time interval, that's the impulse, divided by the mass. Okay, the average force was 4,500 newtons. The time interval was 5 milliseconds, but keep it in seconds. And the mass of the golf ball is 120 grams, 0.120 kilograms. You put that in a calculator and you're going to get the answer. I don't know what it is, but you're going to put it in the calculator. Okay, that is enough information to do your best on the rest of this assignment. Good luck.